And we are back, and the bitrate says that it's excellent. Wonderful. So, what's up? I was finishing to say what things I'm enjoying to interact with you folks. My dear viewers who are not there. Oh, where does it say? Where does it say one actually? And here's 0. I might have a hidden viewer here. And you know, no doubt, plenty of viewers who will dig into the history of my streams one day. So hello to you, archaeologists, and you might want to know that back in the days in February 2021, on the 11th season specifically, I enjoyed that people talk to me about the stream. And, you know, I was definitely still new to this. And talk to me about CRDTs and, you know, distributed data types, which Chronofold is one of. And the idea of composability of CRDTs, which is something that is exists in Ron, who is by the same author as the Chronofold data structure. And talk to me about comonads as a database query abstraction, or maybe even as an abstraction that's not, you know, that's underserved and can be used for so many interesting things. And I know of a few. I'm sure you know of more, and I'd love to talk about it. And Purescript ROM streaming. It's a really interesting point in the design space. Oh, my bitrate's unstable again. Oh, that's unfortunate. Says keyframe interval too high. I see. Well, internet connectivity is against me now. I see. Well, this time though, I am recording. So, well, it is what it is. Let's see when a viewer comes in and gives me the live feedback about how bad it is. And I am going to put some a sweater on. 1 second. Much better. Okay, so what do we have? Yeah, talk to me about Purescript run streaming. That's an awesome library. It's coroutines, but with done with extensible records. And so I think there is a theoretical relationship with monadic stream functions in the style of Dunai, and which I already sort of in some composable might be extending it because it's based on monad stack transformers, monad transformer stacks, and Rhine with type level clocks. But I think there's an equivalency here, and we're going to get to that at some point, and use it in at least use Purescript run streaming in the Chronofold world, and then I'm actually also starting to look at Dunai for Haskell, Rhine and Dunai for Haskell. So this will show up. And also talk to me about reactive notebooks. Like that's, I think, is close to the future of programming. Yeah, we won't get to that until much later, but we will get to this at some point because it's amazing, and we should. So that being said, let's get on with the program, and that's Purescript and Chronofold. So what's up with Purescript and Chronofold? Let's see. Since I've been going through my logs, I am going to also talk just a little bit about why I use Purescript, right? And use Purescript, which is a strongly typed, purely functional programming language, because it gives me a number of things. Pure functions and immutable data structures are a key feature of Purescript, and they together remove a whole class of bugs. And that's really amazing. It doesn't make your code bug-free, but definitely removes like whole classes of bugs that you would otherwise have in other programming languages. Not only that, but the compiler is also helping me remove bugs, because it's, it's basically me telling the computer or the compiler, hey, this function's supposed to take this in, and I'll put that out, and the compiler helps. And yeah, your language might have types. You might be a Java or C++ person, but the type inference that you get with Purescript and Haskell is really amazing. Plus, the power of the types of Purescript and Haskell is actually much stronger. And you can get to abstractions that are really amazing tools to think and reason about your problem and structure your code. And that's been true, very true. And you'll hear many functional programmers say that after a couple of years into starting to study functional programming, I was starting to see my former programming languages that I used and the project that I was working on in it, starting to see them in a different light, because really functional programming helps you think better. And the patterns are really reusable. That's really what these abstractions are about. It gets, abstraction is not necessarily easy. You need to understand it. You need to ground it into concrete examples to understand its power. But once you have them, then if they're good, then they're reusable. And that's really important and amazing about these languages. And the specificity of Purescript is that it just runs in the browser. I mean, Haskell also runs in the browser, but Purescript is pretty much designed to do so. So give me a second. I had to blow my nose. You're probably hearing it getting a bit stuffy. It is minus. What it is? Minus what today? -5 this evening. So they're quite cold here. All right, Chronofold, which is the foundation that we're using for this prototype, and that we built a library for in Purescript. Is a data structure for real-time synchronization of text. The CRDT, which is an abbreviation, an acronym for conflict-free replicated data type, and used for real-time synchronization of text. It's a bit like Google Docs, right? Where many people can read and update text all at the same time, while the results being completely consistent, meaning whatever order people enter their changes, they will all end up with the same result, including if some of them go offline and come back later. So that's pretty powerful. Obviously, when people go offline and come back later, then you might want to do some stuff so that people are not too surprised to see a whole bunch of text coming in, but at least the fact that everybody converges, that really gives you very nice guarantees that you want for distributed stuff. And it doesn't require a central server, right? I didn't even write that without a central server. And what we've done with the Purescript Chronofold library so far, which I've published a version of on GitHub, is implement the basic algorithm and some of the aspects that were in the paper. Did some performance metrics, just so that when we improve it, then we know where we started from. And then we are started on this prototype with this rough idea that, it'd be nice to have this log published as a Twitch extension, so that actually you could change it while I'm writing it, or where you see it on screen. It'd be quite a fun way to interact. although potentially also disruptive. But if it gets disruptive, we'll deal with it at this point. So we went through a couple of iterations for the prototype already. We tried to hook it up into Visual Studio Code that I use here as a Visual Studio Code plugin, but the interaction with the text buffer was not low level enough. So we went to like a more full Purescript plus, I should say. When we did that, we were bogged down in JavaScript, and it was starting to feel very unpleasant. And whereas now that we are doing this browser prototype in Purescript, we for sure encountered new challenges, but these are challenges that I like to solve, as opposed to some of the like complex, hard to reason about API design that we had to face when we were doing Visual Studio Code plugin. And we went through a few things already in this prototype. Obviously, we're in episode 9, so we did do quite a bit of work. And some of that was just to start a simple browser text area, and which I think you saw at the beginning, right? And the idea would be to, I think I didn't write everything that we did. In fact, we hooked it up to the Chronophore library such that when a keyboard event is entered, that it gets appended into the Chronophore data structure, and that also we construct an operation, which is the one that gets appended to the Chronophore data structure, which can also then be sent to the swarm for distribution. And for that, we have hooked up HyperSwarm, and we've succeeded in connecting 2 browsers. And then we bumped into this difficulty of trying to use this library called SDOM, which we did a few episodes specifically on when we walked through it. And it seemed that I had to actually patch the library to make it do what we wanted to do. Which is to do some side effects in a place that was, it seems, not anticipated in the library design, or at least maybe, or that the library design tried to prevent actively. And we learned a few things about applicative effects and whatnot, but we had to patch it. So it could be that at some point we switch, but I think I probably, since this is a prototype, I'll go forward with it unless we really bump into a big problem again. This is not relevant anymore.